Hello students, in the previous lecture we had derived an expression for gradient of a scalar point function. Now in this lecture we'll derive an expression for divergence of a vector point function in orthogonal curvilinear coordinate system. So let a vector whose components are u1, u3, u2 and u3 in these curvilinear coordinates, orthogonal curvilinear coordinates, be a vector point function of orthogonal terminal coordinates and u1, u2, 3, which is continuously differentiable. Differentiable since a is a vector, so we assume that the component of AR is equal to a1 unit A, a2 unit A, a3 unit B. It is equal to a1 unit E plus a2 unit E plus a3 unit E. E1, E2, 3 are the unit vector orthogonal in orthogonal curvilinear coordinate system, and a1, a2, 3 are components of vector A along e1, e2 and e3 respectively. We know that e1 is equal to e1 is perpendicular to e2 and e3. So e2 cross e3 is equal to e1, and e3 cross e1 is equal to e2, and e3 is equal to e1 cross e2. Means the vectors are mutually orthogonal each other. Therefore, this is hold true. And the the relation between the tangential and normal unit vectors are unit vector e1 is equal to h1 del of u1, e2 del e2 vector e2 is equal to h2 del of u2 plus e3 vector is equal to h3 del of u3. Now substitute e1, the value e1 in their other product, in the product of other two vectors, cross product of e2 and e3. This step to remember here. So remember, otherwise you don't reach at the conclusion to see. This now, and then substitute the value of e2, e3 and e1 along the normal vectors. And unit vector values of unit vector tangential vectors in terms of normal vectors. Now we got here in terms of component vector h2 h3 a1 h2 h3 del of u2 cross del of u3 a2 h3 h1 del of h3 del of u1 3 del of u1 plus a3 h1 h2 del of u1 del of u3. Now find the origin to find divergence vector function. That's what we see that del dot. Now find operate del dot a vector. Del dot a vector. Del dot a vector. Del dot first component. Del dot second component. Del vector. Now take the first component. We take the first component here. So del of this is scale point. Del of phi. This is scale point function. This vector. Del of del dot divergence of phi into f vector is equal to del of we have proved this result. Del of scale function to vector function is equal to scale function for point function is del of f vector plus f vector into del of scale function, and del of f cross g vector is equal to g vector dot curl of f vector minus f vector dot curl of g vector. So using these results, so this is equal to first using this result. So del dot this psi dot f is equal to psi is this del of f vector cross over 2 vector is vector quantity plus f dot del of this. Now this is here del dot f1 f vector into g vector. That is we have g vector. Substitute this value here in this and this in these components. Substitute value here. So after substitution of value here, we will get the first component will remain as it is. First component this will be equal to del dot left hand side same. This is it. When you substitute this component value this here, this will this is equal to del dot f cross gx is equal to f cross g is equal to how much? This is equal to del of uh, this is del of f cross g vector. This as it is del of f cross g vector is equal to del of u3 del of this g vector del of f vector curl of f vector minus del of g vector dot curl of f vector using this and leave this set and in place of this in this component convert that into again e1 into unit tangential vectors. We are discussing the first component only. Similarly, you can do the other components also. And also we know that we proved this result curl of gradient of phi is equal to 0. Curl of gradient of phi. This is due to the scale point function is 0. Curl of gradient of u3 is 0. So curl of gradient of this is 0 and this is 0. Substitute the values. The first component that is 0 and 0. 0 this will become 0 term and this will be equal to h2 h3 will be common and this will be equal to e2 cross e3 is equal to e1. E2 cross 3 dot del of h1 h2 h3 e1 h2 h3. Right? Now del of phi is equal to this. You know del of phi is equal to the gradient of scale point function in the Kelvin coordinates. We proved this del of phi. Now in place phi is h1 a1. This you have to find the value of this equal to h1 a1 h2 h3. Substitute in place phi a1 h2 h3. Right? H3 and substitute this value. This del phi is outside del phi here. Substitute value of this del phi here. E upon this will become e1 upon h2 h3 dot substitute value this dot this one. Now find the dot product of these vector e dot e is equal to 1. Other components 0. So we are left with 1 upon h1 h2 h3. The partial derivative is u1 of e1 h2 h3. So del of how many we have to calculate the value del of del dot a1 h2 h3 of del of u2 plus del of u3. So input del of u3 what we got here? We got this equal to similarly how can you find similarly the of the components del dot a2. So a1 h2 is this a1 del dot a1 a2 a1 is this we calculated this is here. So similarly del of a2 h3 h1 will be equal to how much? H1 is to 3 a2 h3 h1 like this upon computers. Yes, also similarly del of del dot a3 h1 h2 will be into and I will integrate into v1 plus into 1 connected to the u3 of a3 vector h1 h2. Now substitute the values. Substitute the value in this equation. Substitute the value in this equation. This components. We got the divergence of A will be equal to this is 1 upon h1 h3. In the first component is u1 in place h1 a1 component of the push vector is equal to second component partial to u2. This component of the push vector u2 component of this is equal to remaining components of this HCH1. This is the value. Now these the equation of gradient of scale point function and And also the divergence of vector point function will convert. You must remember them there by comparison, and we'll take them to the equation in the spherical coordinate as well as the cylindrical coordinates. So by comparison, we drag this result. If you're asked to find the equation in the spherical coordinates, first we'll find the equation in the spherical coordinate, then compare the unit vectors and components and substitute. We'll get the equation of this gradient of a spherical point function, and similarly of the divergence of the vector point function in the current coordinates. Thank you.